All right, so the do now question from Monday was this. The images below both show New York City. The one on the left is a model. The right is a photograph of the actual city. In mathematics, we call these two things similar. Explain what we mean by similar. Now, in the world of mathematics, when we say similar, we're saying that two things have the same shape but different sizes. Just as in the image here, the model has the exact same shape as New York City, but at a much smaller scale. All right, so today we're going to introduce the idea of corresponding parts of similar polygons. And it says this. In the diagram below, triangle ABC is similar to triangle DEF. You can write triangle ABC is similar to triangle DEF as the triangle ABC, and then we use that symbol that you see here, similar. Okay? Now you will notice that that is very familiar because previously, when we talked congruence, we had that symbol as a part of it. Note that that symbol means same shape. And then, of course, the equal sign in the congruence means same size. So congruence is same shape, same size, but similar is just same shape at a scale, different scale factor. A similarity transformation preserves the angle measure so that the corresponding angles are congruent. So you'll notice that the angles that are in the same position have the same measure. A similarity transformation also enlarges or reduces side lengths by what we call a scale factor. So corresponding side lengths are what we call proportional. Let's take a look at example 1. On example 1, it says in this diagram, triangles RST is similar to triangle XYZ. We want to find the scale factor from RST to XYZ, meaning we're going in this direction for our transformation. In order to find the scale factor K, we will take one side of our image and put it over one side of our pre-image. In this case, it doesn't really matter which side we use. So how about we use XZ and TR? So we're going to take XZ over TR because those are corresponding sides. And we see that we get 15 over 25, which reduces to 3 over 5. So the scale factor that takes us between these two triangles is times 3/5, meaning the second triangle is 3/5 the size of the original. Part B, list all pairs of congruent angles. So the simplest way to do this is to use our similarity statement to help us. First position connects with the first position. So angle R is congruent to angle X. We see they're both in the first position of the similarity statement. Then we see that angle S is in the middle and angle Y for the other. So those are congruent. And lastly, angle T is congruent to angle Z. The last part, write the ratios of the corresponding side lengths in a statement of proportionality. So what we're going to do is we're going to take each pair of two sides and we're going to write them as a ratio. So the first one we already had, right? XZ over TR. Our next one, let's do ZY and TS. So ZY over TS. And then our last one, we will do XY over RS. Now, if we actually plug in the values for each of these side lengths, we will see that we get the same ratio of 3/5 for all. Now it's your turn to try. In the diagram, triangle JKL is similar to triangle PQR. Find the scale factor from JKL to PQR. Then list all pairs of congruent angles, and write the ratios of the corresponding side lengths in a statement of proportionality. Pause the video here to give it a try. All right, so the first thing we wanted to do is identify the scale factor. Once again, we are going from JKL to PQR, meaning we will take one side from our image over its corresponding side on our pre-image. So in this case, we have our QR over KL, which gives us a 6/4 or 3/2 scale factor, meaning Our second triangle is 3/2 or 1.5 times as big as the first. Then it wanted to list all pairs of congruent angles. So we know, just like before, we can match based on the order. So J is congruent to P, K is congruent to Q, and L is congruent to R. And then last but not least, they wanted us to write the ratios of the corresponding side lengths. So we know QR over KL, and we know PR over JL, and then we know QP over KJ. All right, example 2. In the diagram here, triangle DEF is similar to triangle MNP. Find the value of X. So we're going to be going from DEF to MNP. So first thing we want to do is identify our scale factor. Now remember, we can get that scale factor by taking any two sides, right, and writing them as a ratio. Remember, we always start with our image, which is the second triangle, the one we're going to. So we have here 18 over our first corresponding side, which in this case is 15. If we reduce this by, it looks like not by 6, sorry, by 3, we're going to see that our scale factor is 6/5, meaning to get any side from the first triangle to become the second, we'll multiply by 6/5. Now note in this situation, if I go from the top triangle to the bottom, I have to multiply by 6/5. So if I'd like to reverse that, I'm going to multiply by its reciprocal, so 5/6. So I want to know what X is, and I know that X corresponds to that in P, or 30. So in order to get X, I'm going to take 30, and I'm going to multiply by our 5/6, because we're going in the opposite order here. So times 5/6, and then here I have 30 times 5 over 6, but it's probably going to be simpler if I go ahead and do the 30 divided by 6 first. 30 divided by 6 is 5, and then 5 times 5 is 25. All right, now it's your turn to try. Find the value of X in the diagram below. Pause the video, give it a try. All right, so once again, the first thing we want to do is find our scale factor. So we're going from left to right, and so our scale factor can be 6/12, or 1/2. Now, in order to get, so we know that that times 1/2 takes us this direction, but if I want to find X, I need to go backwards. So the opposite of 1/2 is 2/1, or times 2. So in order to get X, we know that it compares or corresponds with RS. So we're going to say that X is just 4 times 2, or 8. All right, example 3. In this diagram, triangle TPR is similar to triangle XPZ. So we're going in this direction. Step 1, like before, find our scale factor. So we can see that this side and this side, they match. So we could see that we have 16, because 8 plus 8, over 12. This reduces by 4. So we can see that our scale factor is 4/3. Now, and ultimately, we would like to go this way, because we want this length here, PS. So we're going to multiply by 3/4. So we can see that PS is 20 times 3/4, which is 20 times 3 over 4, but 20 over 4 is 5, and 5 times 3 is 15. So PS is 15. All right, your turn to try. Find KM, given that triangles JKL is similar to triangle EFG. Pause the video to give it a try. All right, so we're going to take a look and notice that these two lengths are corresponding. We can see that this one is 48, 48, and this is 40 and 40. We see those congruency marks. So we know that our scale factor is going to be 80 over 96. Now this reduces by 16. 16 goes into 80 5 times, and 16 goes into 96 6 times. So we can see that a 5/6 scale factor takes us from left to right. So if I want to go from right to left, we're going to multiply by 6/5. So I can see then that Km is 35 times 6/5, which is 35 times 6 over 5, but 35 divided by 5 is 7, and 7 times 6 is 42. All right, now it's your turn to try. Take a look at your textbook, complete these problems, and then send them my way.